Hey, today's notes are based off of two grade school formulas. That is true. All right, this is based off of grade school and then one extra stretched out concept, which you probably maybe already have done. But the difference between arc measure now, and then let's talk about, we're getting big on I can statements now. I hear we're going to force these down your throat over the next couple of years. I can. Every lesson's going to start with that. I can find the circumference of a circle. I can find the arc measure of a circle. Great. I'll hide this. But we have to talk about what's the difference then between measure and length. And the big difference is arc measure is in degrees. We're not going to find the arc length of this thing, but arc measure, JI, we can get the arc measure. JI is measure. And here's how it's supposed to look. Measure of JI. There's supposed to be that measure out in front. We know a central angle equals the arc that it cuts. So JI's measure is 120 degrees. Now length, this computer drives me nuts every day. Can't ever try to hit up here. You can see me hitting, but it won't hit. Look at this. Try to hit. I'm going to take a hammer and hit that eraser. All right, here we go. All right, sorry. Arc length, all right, is red, in feet, miles, meters, ... It's a concrete, measurable distance. If I was an ant, how far would I? Well, it could be actually a bigger circle. If it's in miles, then it could be me. And say you're doing a circular track, right? How many miles would I walk along that edge if this was the size of that arc length? All right, so understand that difference, and then truly understand this. These are old notes, by the way. Get rid. Did I cross this off? I tend to. There is no. We have no chapter. We have no book. It's annoying, and it's the first time we've done arc measure in arc length and then area questions. So I just kind of grabbed this from another thing. But look at this. We know this then. This is 90 degrees. So arc measure cuts a circle into fractional parts. What fractional part is this? Well, that part is 93/60ths of a full circle, which we should understand that is 1/4 of a circle out there, right? Isn't that simple? Very easy concept. That's why today it ain't going to be no thing, chicken wings. This is 63/60ths because this is 60 degrees, which is 1/6 of a circle. Just to have fun with those little things that we should already know from our previous chapter or section, whatever section that is, whatever chapter we're in. What is that angle measure right there? Arc measure. 3, 2, 1. Tell me. 108. So this is 108. Can someone get their calculator out? Help a fellow out. I think I do have my calculator open. By the way, while you're here, if you have a TI and you still don't know this button exists, you're severely and totally behind in my class. I'm gonna be honest. It's time to get you want to get nuts. Let's get nuts here. Tired of this stuff. I show this calculator stuff all the time. Did you see what I hit? Alpha y equals. So I'll do that one more time. Alpha y equals. Fine, I'll do this one. Hit enter. And now I can do, was it 108? I already forgot. There's my old brain. Over 360. I think this puts it in fractional reduced form. Look at that. All right. Now, I really shouldn't show you that because I feel like this is why students don't know fractions. Can't even move my fat head here. All right. Sorry. What was that? 3/10? All right. There we go. Couldn't remember that. So now this is why we don't know how to reduce fractions, though. My seniors, I'm sorry, seniors, but the idea of a fraction is like they think it's calculus when we're doing fractional multiplication and adding. All right. What is a diameter cut a circle in? What fraction? 3, 2, 1, go. And then here's the argument again, 90, double that is 180, and sure, that is 180. That does look like I should be able to draw a diameter to the two end points of those chords there. All right, so this is certainly half of a circle. All right, 180 over 360. Okay, and that's the idea of this. What's going to happen after this? This is still like in the bell work. Things you should already understand. And you should already understand what circumference of a circle is as a formula. But I know what happens. Hey, what was yesterday, by the way? 3, 2, 1, go. Pi Day. This is what the ancients actually did. I have a book called The History of Pi if you want to borrow it. Anyone? I'll bring it tomorrow. No? Okay. So they actually literally did this. I really only got through one chapter. It's kind of boring. But they literally, in the ground, drew a circle with a rope on a tether. And a tether doesn't wrap around the pole. It stays the same length. And they would measure the circle, and they would count off, through however they measured, the distance around, which is called circumference. And then they would double the rope, because the rope actually ends up being the radius. And then every time they divided, no matter how big the rope was, the circle's circumference divided by the diameter, they come to this magic number pi. It's amazing to them. It blew their mind. And they did not have what we have today, the 3.14 all the way. Anyone see the hallway over there? One teacher went nuts, and I think it was Mr. Stranowski, maybe. I'll have to find out who did it. Was it him? He did it. Okay, good. I just noticed that today. I saw it listed all the way out. Maybe tomorrow my math shirt will be my other pi shirt. I'll tell you that story. We actually had at Wheat North when I taught there. We had you guys don't even know what these are anymore. An assembly. Do you ever hear of an assembly? Where everyone comes to the gym. Those are illegal now apparently. Like when we win a state championship or something. No assemblies. Can't do that. We had a math assembly. It was a full math day on Pi Day. Our math hallway had a bunch of math things going on, and then the last 2 hours of the day we went to the assembly and had a whole Pi Day experience. Then they elected one teacher to get pie in the face on Pi Day. Do you have any idea what teacher ended up getting the pie in the face? It was me. Very popular, I guess, or I was the one that they wanted to smash a pie in the face, one or the other. All true. But anyway, circumference is pi times diameter. But actually, a more popular formula seems to be, what's a diameter? 2 watts. So I'm going to do this because people screw these up all the time. Because area, as you'll see in the next thing, is pi r squared. There's a 2, a pi, and an r in it, and students can't handle which one's which. And then they flip coins, and then they're wrong half of the time. All right? Area has units squared, right? So how can we not do pi r squared? And then therefore circumference is 2 pi r. All right, very simple thing to not screw up there. So anyway, we got that finally. We're going to do 2 pi r, 2 r pi, 2 pi r. Okay, but I'm going to do the r first. Notice it says exact form. So I'm going to do both. Get your calculator out though. Get ready for this. Not this. This is in inches because it is a physical distance that I would walk around the circle. This is exact. When you leave pi in its symbol format, like it's a variable. And it kind of does act like a variable algebraically, but it is not a variable. There's nothing variable about pi. It's an approximation 3.14. Variable means changing. All right, what do you get when you type that on the calculator, 24 times pi? Tell me what you get. 75 and that says, oh, it does say, and rounded. 75.39, did you say? That's the approximate. And then I like this answer because I have a meter stick. What's this called? A yard stick. Isn't a yard 3 feet, right? So that's like 2 of these. Plus a little bit more. That's how far you'd walk, but in a circular direction, not direction, but a circular motion, I guess. You'd walk 2 of these and then 3 more inches in a decimal. So that's a concrete feel. We can actually understand how far we'd actually walk all the way around that circle. Right? So I love that number. I'm able to get that yardstick, and then you're good to go. And then don't ever get screwed up on this. That's 8 for a radius. Or I guess you could have put C equals 16 times pi if you remembered pi times diameter. And that's feet. I don't think I have to do a whole bit. And then you can type out your calculator, get the decimal. We got to move on. All right, taking too much time on this. And then I forgot a 1B on this for my notes here. So get ready to write 1B, because 1 is just consider the gears represented by the circle. And then what I want here, and I'm just going to verbalize this because of time, because we have to get the area as well. We got 27 minutes. This is arc length that we're building up here. What fractional part does this represent of the circle? Well, in both cases, this is 3/60ths of a circle that you've moved, which is 1/6 of a circle. So that was what 1B was supposed to ask. I was condensing notes from a previous resource. Was from chapter 10 with a book that we actually had. So that's what that represents. All right, so now I can go on to the next one. If the length of the radius of the large gear, I want to cover this before we move on. We have a lot of gear questions in chapter 3 in our trig book. We already had this happen. Let me ask you one quick, easy question. When this gear does a full rotation, does the big gear do a full rotation? There he goes with the neck. Does it do a full rotation? It was close. It looked like you were leaning back and it looked at you. All right. So does the second gear do a full rotation? Yes or no? 3, 2, 1, go. No. It's like a bike too. A bike usually has a big and a little, like whatever you call it, spokes or whatever. No, that's the things on the tire. You know what I mean. I guess it is gears. When you do one rotation here, your back tire doesn't do one rotation. All right. So the difference between rotational speed and linear, how much you travel. When these gears travel, and this does 8 inches on the edge, this will do 8 inches on the edge, but it just won't have as much of a rotation as far as how far it rotates, right? Would you agree with that? Right, because the gears are connected, they're stuck together. All right, but anyway, I like discussing that, and that's why I like this gear question from our old notes. The length of the larger gear is 12 centimeters. Find the circumference. Very simple. And we'll leave it in exact. So 2 pi r. I'm doing 2r pi, which is 24 pi centimeters. And there are centimeters on that stick as well. 24 times 3, 2048, something like in the 70s again. Was that the same one that we had before? I don't know. Who cares? All right. Use the circumference found in number 2 and the ratio when made up 1b. Find the length of the minor arc AB. Notice it says length, not measure. I need to know what is the exact distance that I travel from there to there. How far did I go? The answer is not 60 degrees. All right. The answer is an actual distance in centimeters. So what it is, and then you're going to find out later that the word letter S denotes arc length. You're just going to have to remember that, I guess. It's 1/6 of the full circumference. Very simple, easy, basic concept if you've never seen it before. I don't know if you have or not. And then if you put that in your calculator, that's going to be 12 point something centimeters. So I know I have centimeters on here. Here's 12 centimeters. That's how big that arc is. My finger's right here. That arc right here is that big, and that's how far you would walk. All right, 12 centimeters. So that is actually very concrete in understanding the difference between arc measure and arc length. All right, an actual physical distance that you actually travel. Smaller one, circumference equals 2 times 8 times pi, which is 16 pi cms. Same fractional rotation. When gears rotate, we shouldn't count these as connected because they would rotate differently. And then this is, I think, 8 pi over 3. Can someone type that in a calculator? I'm just curious. What's 8 times pi divided by 3? How many centimeters is that? So when it rotates a measure of 60 degrees, what's the distance it actually travels? Is it 8? 8.3. So it is a little bit smaller. It actually is proportional to the radii, by the way. 12 over 8 is 3 halves, I think, or 2/3. One travels 2/3 as far as the others, and that's what you can see in those radii. I think they had some sort of progression on that when I had more written out here, but literally just threw this at you then. Here is your arc length formula, a portion of the circumference. That's all it is. That circumference, so I'll highlight that in this if you're a highlight person. Here's circumference, 2 pi r. And then measure, it should be of the central angle. Hopefully it does have that up in there, the central angle. So the angle is actually the central angle. So it should say central angle there. So on and so on and so forth. Okay, so that's the formula you're dealing with. This first and second one, I'm not doing both. They're both plug-in chugs is really what they are. It says leave your answer in exact form and round to the nearest. Get your calculator ready. So what is the arc length of AB? Arc length, not measure. All right? So arc length is S equals central angle divided by 360 times circumference, 2 pi r, and I keep switching the pi and the r. The radius is 16, so I can put that, and I can put millimeters on later. By the way, 45 over 360 is 1/8. 8 goes into 16 2 times. So I think 2 times 2 is 4 pi millimeters. Right? 45, 90 is 1/4, so 45 is 1/8. 8 goes into 16 twice, 2 times 2. This is exact. Somebody give me, is that the 12.57 we already had? Okay, and then this is the approximate. When you use the pi button or even use 3.14 for pi, now you got a concrete, understandable distance that you can equate to the yardstick or meter stick. You actually know how far you actually go when you put it in in approximate. And I do want to put that's approximate. I don't care I don't care if you wrote every single decimal on your screen. The last decimal is rounded, so therefore it is approximate at that point. Not enough students know that, the difference between approximate and exact. Okay, these drawings are going to come up again. So when I get to area with our last 10 minutes, I'm just going to pound it right through because it's pretty simple here. But here's the measure of AB. What does that measure, everybody? 3, 2, 1, go! Yeah, it's not 75, it's 150. So this is 150 degrees. So the arc length, that's the pen. Love you. There it is again. Nope. No 150 for Mr. Samuelis. And then, you know what? And that's 48. So it's 2 times 48 times pi. I'm not teaching a calculator anymore. You can type it. You can get that without pi being incorporated yet for the exact, and then press the pi button to get the approximate. I should not have to, in an honors class, show you the difference between exact and approximate anymore. You should be able to do the calculations. You have the stinking fraction button. On this one, I would use the stinking fraction button. And don't hit pi yet to get the exact answer. All right? If you don't get that, I don't know what I could do for you. All right, we got to move on. Oh, what a meanie. Given the radius, so you got to read. I got my radius. Okay, I don't see it in the drawing, but it's given to me. Great, great, great. I got that piece of information. Find the length of arc B. Well, wait a minute. I got to be a problem solver. I don't panic. Don't quit because you didn't show me how to do this. You problem solve. You go back to the things that, from our previous chapters and said, okay, wait a minute. Fumble over there. I got angle equal. You can get it. Hurry up. All right. Angle equals big arc minus small arc. Okay. So remember that. Angle, and that's a secant angle, equals half big arc minus small arc. That's what's true. Now what I can do is solve this. We did have ones in our notes that this is the thing that occurred. And then I think the smartest thing to do is to multiply both sides by 2. And then you could just subtract 96. And a negative equals a negative means a positive equals a positive. So when I subtract 96, I think last hour's number was 54. Anyone agree with me on that? So you get negative 54 equals negative x. That means positive 54 equals positive x. All right, but that's just half the battle. Now to get the arc length, I put it in my arc length formula. This is 54 out of 3/60ths times 2 r pi, 2 pi r. I just like write it like that so I can... You know what? This really isn't too bad because that's 120. 120 goes into 360 3 times. How many times 3 go into 54? 18. Did we get 18 pi there? Did I just get that? Nice. I can't believe I did that mental math that quick. I got like 0 sleep yesterday. You ever have one of those nights you just can't fall asleep? Anyone have that? My mind just couldn't shut down. The world, no units. Blah, blah, blah. I won't get into it, but I just felt like crap this morning. Absolute garbage. All right. Anyway, it happens, right, in life. Okay, I guess I have to do this one. Problem solving. Okay, I really shouldn't have to, though. You should be able to look at this and say, all right, I gotta do something, not nothing. I used to tell my CAT students that all the time. Don't do nothing, do something. So given the length of an arc, I have arc length formula. So arc length formula is S equals angle over 360, and that's, we know what that angle is. That's the central angle times 2 pi r. So this is what I'm dealing with. Let me see what I have. Okay, given the length of the arc, that is the length of the arc. That's S, is 12 pi feet. So I can put 12 pi in that position. I can substitute. And then what is the measure? I have the radius. So that's 2 times, how I like to do it, 27 first, then pi. So that's what I'm looking for. I'm looking for the arc measure, which is x degrees. That's where the unknown is located. So this is how you do it. What is the measure of the arc, which is in degrees? Measure is in degrees. Okay, here's the first thing what I would do. I divide by pi, both sides. Just get rid of that. Wrong. I just had a 12 in my head there. I saw that 12 and whatever you do to one side, do to the other. Then the next thing I would do is multiply by 360. That's the opposite of division. I take care of these two things at once. What's 12 times 360? Tell me what that is. 4,000 what? 4,320 feet. 3, 4, 5, 6 feet. And then what I have left is 54x. Because I canceled this. This is why I undid the 360. And 2 times 27 is 50. I just have to divide by 54. By the way, there is feet in here. And then when you divide feet by feet, it disappears. And that's where the angle measure in degrees comes in for your dimensional analysis. That's kind of tough, but that's really what happens. What's the final answer? 80. So x equals 80 degrees. So you're a problem solver. You're able to solve that basic equation with those fractions. Still think some people have big problems with solving. That's why we're struggling in this class still. There's nothing I can do at this point. You're either going to make the decision that you can solve an equation or you're not. And then next year is going to even be a bigger struggle. Given the length of this, what is the length of the radius? It really is the same kind of question, but now you have to find r. I want to move on and get to area. It's really a problem solver like that. I do want to talk about these. They are pretty fast. You have to understand I do have 13 minutes. I think I had 9 minutes left for area last class. So the perimeter of this thing is this. From here to here to here then this, walking around this, which looks like a free throw line almost in a way. But it isn't quite the right dimensions. First of all, you should know that this is 15, assuming that this is a rectangle. We'd have to assume that um, from what's given. And then what does this represent? I mean, with that angle measure, what part of the circle is that? 3, 2, 1, go. What fraction? 3, 2, 1, go. Half. So the perimeter is quite simply you saw me hit it up there. 30 plus 15 plus 15. There's that plus. Love this pen. And then plus half 180 over 360. I forgot something. What's this radius here from there to there? What's that radius from there to there? Luckily, it's 15. Well, just weirdly not related to that 15. It's just half of this 30. Right? 30 would be the diameter because of a rectangle. So 15 is the radius. 2 pi r. And then you can go ahead and this is easy actually. Half of 2. So this is 60 plus 15 pi. That is the exact. And it'd have to be written like this. You cannot add 60 and 15. This is where I said a few minutes ago, or maybe 10 minutes ago, pi does kind of work like a variable, although it is not. But it does work like a variable where 60 and 15 cannot be added. Now, when you go to the calculator, you type this exactly as is, 60 plus 15 pi, press enter, and you get the decimal. What decimal do you get there when you type that? 15 times 3 is probably like 45, so 100, 108, 107. Is it 107? 107 what? Let's go 2 decimal places. 0.1 what? 2, and then that would be actually centimeters, and then we could actually get a physical distance on that over there. And then one more thing. Good. Perimeter of the shaded region. So this walk, then we walk here, then we walk here, and then we walk here. What's that distance there? First of all, we should know we got 20 and 20. So that's 40 plus. And then how much of the circle does this represent? 3, 2, 1, go. Half. And then how much does the circle does this represent? What's a half plus a half? A whole. So you actually have the whole circumference. By the way, what is the radius? 4. So it is 2 times 4 times pi. It is a full circumference when you put the two parts together. Because this is being noted as the center, so we know we have half a circle and half a circle, which is a full. All right, so that's 40 plus 8 pi, not 48 pi. And then this is in yards, which is that's a big one. If it was real world, yards are large. Okay, and then super fast to area. This is why on area, we get it. We get the idea of dealing with a portion of a circle. So I went right to this for area. This is it. The area of a circle, we should know, is pi r squared from grade school. We literally should. And if you don't, these are the things that you didn't do back in the day that you should have. And then these things are the things that keep hurting people in addition to other stuff, that we talk about that we're supposed to know when we walked in. All right, that's actually not what I wanted. I was looking for central angle, but we know what measure of angle is, whatever the central angle is. And then I think these drawings are all the same. Oh, let's go to this one. Let's go to 2, because I ignored 2 in the other set of notes. But what's the area of the sector? That is this space inside. That is different. How much area is in that? And then why do we do units squared? I'm going to try to draw this even though it's going to be obnoxious. But we do have a central angle of 80, so we're dealing with 83/60ths. And then what is the radius, or what is the area? It's the radius squared times pi. So it's just 83/60ths of the whole area. All right, let's do exact and approximate one more time. Oh boy, I'm going to go ahead and do this. 80 Wrong. Clear. Let's be cheating bums and use that fraction button. 80 times 10 squared, which is a hundo, divided by 360. Notice what I did not type. I did not type pi because I wanted the exact answer, 200 ninths. 200 ninths times pi inches squared. That's exact. And then when I go to this and times that by pi, which I do have that right there, then I'll get that obnoxious number, 69.81. 69.81. And then this is often a symbol, 69.81. Was it inches? Okay, it was inches. Now, what that means and why I put inches squared is I can't draw this, but there would be 69 inches squared that would fit in this. These are 1 by 1 inch squares in there. I can't do it justice. That's why we put inches squared. 1 by 1 inches squared. This is why it's impossible for it to be, a perfect amount of squares. Squares don't fit in circles very well. But that's what that means, so you understand why we have that label inches squared. So I love teaching area and, looking at area the correct way there. Isn't this the same drawing as the other one? I mean, I don't think I have to keep doing this. What's this angle measure from here to here? 3, 2, 1, go. 150. So this is 150 over 360. Read area of sector A to O to B. What is all that space inside? Not the arc length, the area. So I need area formula. Okay, that should be enough. 48 times pi. Squared. Whoa, I almost screwed up there. Pi r squared. So I have the radius squared there. Just showed you how to type that on the calculator. Shouldn't have to do it again. Okay, and then I guess I have to do one more of these. Oh, good. I have 6 minutes. We have to do one more thing at the end of this. So area of a sector, sometimes it's written like this, equals, let's just put angle over 360 times pi r squared, and you problem solve. Given that the area of AOB, well, there you go. The area of A to O to B, that's how you name a sector. You call it a sector and name the three, including the central angle part, that center, is 27 pi inches squared. What is the diameter? Read. Okay, I don't have diameter in this though, but once I get the radius, what do you got to do with it, everybody? 3, 2, 1, go. Double it, some people mumbled. And I do have the degree measure, 120 over 360. And then pi, I did that last hour too. I don't know why I put another equal sign there. Times pi r. Oh, I have to find r. Got it. I think the smart thing to do on this is A, divide both sides by pi. Get rid of that. The pi's go away. Okay, so that's nice. And then this is actually 120 over 360 is 1/3, right? How do I get rid of 1/3? I multiply both sides by what? 3. These are simple math things. This drives me nuts. Whoa, what'd you do? And then people almost fainting on that because you don't know your dang fractions. Oh, it's so frustrating as a teacher. It's like such a hindrance in my CAT class. It's just ridiculous. 81 equals, this cancels with this. That's gone. I have r squared. Now, technically, r equals what? When I square root both sides, what should I put on that 9? Plus, say it. Plus minus. Does minus make sense in this circle question, yes or no? Algebraically, don't forget about the plus minus. Geometrically, it's only r equals 9. All right, so, and it is 9 inches. I probably should do better dimensional analysis why it turns into inches from inches squared. It's when we square root, inches squared become inches. That's really what happens. Just like the square root of x squared is x. All right, same idea. So there's your dimensional analysis. True that. Okay, so any question that mentions segment, if you can figure it out, go ahead and do it. If not, we'll talk about it tomorrow. All right. It's really not a big deal, though. I bet you if you put a little bit of thought into it, you'd figure out how to find the area of just this part right there. It's a very simple, basic concept. All right, but we ran out of time, and I got to run around and give you your homework. And we, oh, we won't have time to staple. I don't think. Oh boy, let me end this video that no one's gonna watch. Well, wait, we do have some absences, so you never